Hi, I'm Max, and today we're going to talk about solenoid valves. There's a wide range of solenoid valves on the market, and with this video, we hope we can inform you of the main solenoid valve features to make a more informed decision when choosing one for your application. We will cover control principles, circuit functions, material selection, determining the right size of your valve, the response time, and the voltage and coils. First of all, the different control principles. There are three different solenoid valve control types: direct, indirect, and semi-direct. A direct acting solenoid valve works from 0 bar, is generally for smaller flow rates, and doesn't require a pressure differential for operation. An indirect acting solenoid valve requires a pressure differential of half a bar and has a small solenoid for a comparatively large flow rate. A semi-direct acting solenoid valve is a combination of a direct and indirect solenoid valve. It works from 0 bar and has a relatively small solenoid capable of controlling a large flow rate. Second, we will discuss the circuit function of solenoid valves. Typically, solenoid valves are either two-way or three two-way. The first number indicates how many ports they have, and the second number indicates how many different operation states. So a two-way valve has an inlet and an outlet that can either be open or closed. A three two-way valve can have 2 inlets and 1 outlet, or 1 inlet and 2 outlets. Third, we will cover the materials. Common sealing materials are NBR, EPDM, FKM, and PTFE. The most common housing materials are brass, stainless steel, and nylon. Click in the video above or in the link in the description for more information about these materials. Fourth is determining the right size for your valve. An easy method is to compare the diameter and the threaded connection with the pipe diameter. For example, a half-inch valve is a common size for a 15mm pipe, and a 1-inch for a 25mm pipe. Make sure the bore is not smaller than the inside diameter of the pipe to limit the pressure drop. Note that some valves with a large thread size can still have a relatively small bore. An accurate way to determine the size is to use the so-called kV value. This value indicates how much water flows through the valve at a pressure difference of 1 bar. There are simple formulas to calculate the pressure drop for a specific input pressure with the kV value. There are different formulas for liquids and gases. To make it easier, you can also use the kV calculators on the Tameson website. Fifth is the response time. Solenoid valves are known for their quick response time. The response time is expressed in the time it takes from activating the coil until the valve is opened or closed. DC valves are typically 50% slower than AC valves. A direct acting solenoid valve is generally faster than the same size indirect acting solenoid valve. Common response times for small direct acting valves is 5 milliseconds, and for larger ones roughly 50 milliseconds. For indirect acting valves, typically 150 milliseconds for smaller valves and 1500 milliseconds for larger ones. Keep in mind that the small response time can cause a water hammer, then opt for a valve with a longer response time. And lastly, we will discuss the coils. Coils can be specified for AC or DC voltage within a wide range. Typically, it is decided by what is available at the point of installation. A frequently asked question we get is whether the direction of the flow through a DC coil is important, because most coils have no indication of polarity. And the answer is that polarity doesn't matter. The power supply can therefore be connected in both directions. So if you have any questions about selecting the right solenoid valve for your application, then please contact me or someone else from Tameson.